What we've done now is we've reversed the wiring in all three phases, and we find no difference in results. But here we want to look at the phase rotation aspects. Here's the condition without phase 1 employed. Only phase 2 and phase 3 are employed. We find that on our voltages. We have an open circuit voltage of 1.2 volts on the empty phase. We have a very loaded 0.2 volts on that amperage conduction, 0.148 amps. Notice that the values are very semi-stable, not cyclic. Now on phase 3 we have 0.232 volts, and oh, pardon me, we made a mistake here. On phase 3 we have 0.2 volts enabling 0.222 amps. On phase 2 we have a full volt enabling 0.146 amps. We're now going to proceed. Then we've showed the relationship between 2 and 3 on our stator amperages. They seem to be fairly balanced. Well, not really balanced, but could be a lot worse. We're only employing 2 phases. Now we notice that in this situation we have 1.2 volts on the empty phase, number 1. We have 1 volt on phase 2, and we only have 0.2 volts on phase 3. So what we're going to do now is disconnect phase 3. Okay, now we only have 1 phase. We notice that our input voltages have universally gone up. We now have 1.2 on the let's see in here. We again have 1.2 volts on the empty loaded phase number 1. We now have 1.3 volts on phase 3 and 1.3 volts on phase 2, and we also have on phase 2 a resonant rise of 6.7 volts and an amperage of 0.269 amps. At condition 1.3 volts. Now what we're going to do is we're going to go back in and engage phase number 1. Now problems here are universally noted on this system on the imbalance of stator line amperages. This is completely impossible, but this is what happens. Since we only got 1 phase employed, if we can look at our signs there, we've got 1-2 and 2-3. Those amounts should be identical and identical to that amount as the solitary phase that we're employing. Why does the 1 stator line record an excess of 0.10 amps? This is the deal here. We are finding excessive stator line amperages all along the system. We go back now and employ phase number 1. We got 0.27 on phase 2 at 1.3 volts. We're hooking up the 1.2 volts up. Now we got there. Phase 1 dropped from 1.2 volts open circuit to 0.8 volts. That's producing 0.12 amps. And looks like we got an increase, as I do recall. Yes, we do have an increase on phase 3's voltage. Phase 2's voltage has been decreased according to load. It was 1.3 if my memory is correct. Yes, it was 1.3. 1.3, it's been decreased to 1.1. And now it's producing 0.300 amps. And so we have to conclude then that phase 1 must be producing current on phase 2. And then we look at phase 3, it's 1.8 volts now. And it's not producing any amperage. So we'll go ahead and finish out and plug in phase 3. When we plugged in phase 3, it looks like phase 2's amperage went up, but voltage went down. It was 1.1. Phase 1 has now acquired a very low relative voltage from starting point. It has gone down to 0.3, and it's enabling 0.15 amps. So then we've got 0.9, enabling 0.34 on phase 2, and finally reduction of phase 3, 0.4, enabling the 0.18 amps on phase 3. And there then is our division of stator line amperages. Now we're going to go in there and turn the field on and look for any kind of ratio changes between the stator line currents, which are were formerly noted to be excessive. 0.15, 0.34, yes, they're still excessive. Stator line 1, 2 has been formerly measured to have 34% excessive amperage versus the phases it serves as 1 and 2. Turning the field on now. And there is the operation of the machine as formerly noted. And it's not doing exactly the same thing as the first version. Let's go over there and look. That's our ratio of amperages, our new voltages. Formerly we had 0.3 volts, phase 1. Now we got 0.8 volts, enabling 0.3 amp, 0.317. Phase 2, now I have 1.9 volts, enabling, well, that's cyclic again, 1.7, 1617. And that's on phase 2, and it's enabling these cyclic quantities to occur. And we'll go look at the interphasal voltages, and I'll probably call it quits for this video. The interphasal voltages do not appear to be nearly as high. Formerly these were in the 20 to 30 range. So then this becomes necessary to try to formulate any kind of change in the acting phase angles based on this information. So then we need to spend a few minutes here and try, if we may, on our interphasal voltages. We've got to get this up here so that we can see those three quantities and those three quantities. The yellow meter showing 7 volts and cyclic activity up to 8. 1 VI. Meter next to it 14.3, 13.6, 12 cyclic activity. Phase 1's at 0.8, phase 2's at 1.6 volts, double, and phase 3 is at 1 volt. Pretty even division of voltage distribution there. And phase 3 has an internal voltage rise of 10 volts. If we can capture that. Now again, trying to get all these meters in perspective. And note conclusively that we have not seen it go up into the 30 volt range, but that could be due to the variac setting. We're going to go and increase, make sure that's a 20 volt variac. Not at a 20 volt variac, that was at a 16, and we see now this is exactly what the former conditions reveal, and so then we will call it quits.